Hopefully this will allow them that aren't here to see the videos. My only hope until we get this fixed. All right, no questions through 5. How about 6? The GCF for those two monomials, by the way, fancy word, monomial. Remember what a monomial is? It's a combination of a coefficient with a variable, and it could be more than one variable as long as it's written as one term and there's no plus or minus in between them. That's a monomial. Once you add something to this or subtract something from it, now it becomes a binomial. It's not a monomial anymore. So how 6a, if I look at those two, I need you to focus there. Do you understand how 6a would be the greatest common factor?
Yes.
Look at the numbers, 12 and 18. What's the greatest common factor for 12 and 18? What's the largest number it goes in a boat? 6. Okay. So that makes sense. And then you've got 2 A's and 1 A. What do they share in common? How many A's? 1. Come on, notice how I'm doing this. And then you got no B and 1 B. What do they have in common? You don't have a B in common. Boom, there's your answer. I did the numbers, 12 and 18, 6. Please stop the extra chatter. And then I looked at the letters. They didn't share a B, so that's out. They shared 1A. One of them have an A squared. The other one just has an A, so they only share 1. So that's the answer to number, what was that? 6. Number 7, Z squared. Does that make sense, Capri?
Yeah, but I was just going to say that.
Can't hear her. She's right in front of me.
With larger numbers, you want to do the prime factorization and compare.
Right. So Capri's like, she sees what I just did there by looking at 12 and 18 and breaking it down in my head, right? The whole idea here is that you use prime factorization. The whole idea is that you break them down to the smallest parts and then you compare them. Because it's not going to be always, like I always say, it's not going to be always so easy to see that 6 is the GCF for 12 and 18, and then they share 1A and they don't share any B's. Does that make sense? Jake, go.
So for a monomial, why is it? I'm trying to get a way to remember that greatest common factor is actually the lesser version of words. I can't say it. Yeah, that word. Monomial. Is there an easy way to remember that in the greatest common factor that you use the least common monomial? No.
Well, I think you're confusing something. What do you mean use the least common?
So it's 12A and 18AB, like 6s. In least common multiple, it's
least common multiple would not be 6A.
I know. I'm just saying in 6, 12A squared and 18AB, it would be 12A squared for the least common multiple. But how is there an easy to remember that it's a different way?
It wouldn't be 12A squared.
I can't ask this question.
Okay, if you were looking for, let's say you're concentrating on 6 because we're going to do common multiples in the next section. But if you were doing the common multiples for number 6, it would be 36A squared B.
I know. So is there any easy way to remember that squared for you use the greatest for the least, and you use the least for the greatest?
I don't think he knows what factors and multiples.
No, I know the difference. I'm just saying.
You're getting them confused.
I know. I really am. I don't like
So you just ends it with I don't like that.
Yeah.
Number 7.
Why do they get words? I don't.
Everybody understands 7. Why is Z squared the greatest common factor? It's the only thing they share. One's got a 2, the other's got a 3. Those aren't shared. One's got 3 Z's, the other's got 2 Z's. They only share 2 Z's. Number 18, 14R. I'm sorry, number 8, 14R. If you look at the 14 and the 42, what's the greatest common factor for 14 and 42? You might think it's 7, but that's not the greatest. That is a common factor, but it's not the greatest. If you take 14 and 42 and factor them out, you end up with
14, or 2,
2, 7, 7. 2 times 7, 14. Yeah.
For number 7, so for like the whole exponent thing, it's not the actual exponent, like the how much you're multiplying that. It's not like what that is in common. It's actually like inside the exponent, or like 3 and 2. It's like, let's say it's like 7 and 5. It would just go down to 5. Isn't common. Like
No.
Z, he's talking.
5 is not in common with 7 because they don't have a common. 5 and 7
No,
are not.
that's not what I meant. I meant so if you're multiplying Z to the 7th power
Mhm.
and Z to the 5th power, it would be, what they have in common with Z to the 5th power. Is that right?
Yes.
So, yes, that's what I meant. Oh, so it'd be
No, I'm
Z-
sorry. They share.
He's talking like me.
They share Z to the 5th.
Yeah. So okay. Yeah. I thought it was like actually like next course.
All right. Number 9, least common multiple. The rule is now you use all of the prime factors to their greatest power. Arithmetic wise, Allison might look at number 9 and go, I know my times table's for 4, and I know my times table's for, well, I don't know for 16 or 32. But if she wrote them arithmetically, she would go 4, 8, 12, 16, 20, 24, and so on, 16, 32, 48, and so on, 32, 64. The first one she would come to is, anybody?
32.
32. Wow, yeah. So 32 is the least common multiple. How would that look as prime factors? What if you did that by using the prime factorization method for 16 and 32, right? You got 2 times 2, or 2 squared. You got 2 times 2 times 2 times 2, or 2 to the 4th. Stop. You got 2 times 2 times 2 times 2 times 2, or 2 to the 5th. So you use every factor to its greatest power. The only factor they have is 2, and the times power is 5. Does that make sense? You knew that looking at it using arithmetic, and it proves it using prime factorization. 2 to the 5th. Next one, number 10. Does that make sense? 72 is your answer.
Yes. Yeah.
24, 48. How many hours in 3 days? 72. What else goes into 72? 18, 36, 54, 72. 36, 72. You can do it arithmetic-wise, or you can use prime factorization, break them, all 3 of them down to their prime factors, use every factor to its highest power. I'm going to throw some confusion at you. Ready? What's the rule for finding greatest common factor? Good.
Use the numbers and variables together.
Only use the prime factors that they have in common. What's the rule for finding least common multiple? Yep. Use all the factors, but only to their highest power. So here I have a 2. But I got 2 to the third, 2 to the fourth, and 2 to the fifth. Which one am I gonna use?
Like,
To the fifth. I'm gonna use it to its highest power. Once again, what's the rule for finding greatest common factor? Only the common factors. Only the common factors are used. Multiples, you're using all of the factors, but only to their highest power. You're just gonna have to say that to yourself over and over again. So that when it comes to the test tomorrow, and you're looking at those two sections, greatest common factor or least common multiple, you've got that drilled into your brain, those two sayings. You with me? Yeah.
we don't let them notes.
You're allowed to write notes on your test?
No, have notes.
Not usually.
You might have a calculator out.
Is that?
Is that a yes or no?
That's a no.
Look at the rest, look at 11 and 12. 11, does 11 make sense to you? That might not make sense to you. Look at it. The greatest common or the least common multiple for 5 and 21.
It kind of does. Yeah, it makes sense.
Okay?
2, 2, 2.
What about for x squared y, xy cubed? Use every factor to its highest power. Both of them have an x term, don't they? One of them has just an x, the other one has x. One of them has, what is it, y squared, the other one has y cubed. Which one are you using?
No, it's just Y.
Just y to the highest power. Use it, use every factor when you factored it out to its highest power for this section. Yeah,
Is it, like for this one, so it was 5x squared without the y, would you still factor it as y cubed when you work it out? Like would the y still be there if both numbers would have it? You know what I'm asking?
That is so mad.
So, for number 11,
Yeah.
if instead of it being 5x squared y, if it was just 5x squared, the
okay.
y wasn't there, but it was still there in 21, x, y squared. Would you still put the y in?
You still have y to the third?
Yeah.
Yeah, because you have to use every factor. Right, because when it comes to least common multiple, it doesn't matter if they're uncommon. You use every factor to its highest power. When it's greatest common factor, you only use the common ones. For least common multiple, you use all of them, only to their highest power. I don't think I've said that enough. I don't think you've said it to yourself enough. I don't think, unless you're, I think that you better keep saying it to yourself, so when you come in tomorrow, you don't mix the two up. When you're finding GCF, greatest common factor, you use only the common ones. When you're finding least common multiple, you use all of them, but only to their highest power. Yeah.
So do we have a double period tomorrow? Are we gonna, like, for the test, is there gonna be a time limit, or is it just gonna?
Is there ever technically a time limit? I mean, you have a period to take it, right? But in the 2 years you've had me, I don't take tests from kids.
Oh, don't
I mean, you might have to leave